Oh, welcome back, Science 10s. Mr. Thompson here. We're just finishing up 2.2 in Unit B on potential energy. So we're looking at catapults and trebuchets. In the Middle Ages, 12th century, catapults and trebuchets were used to throw very heavy stones, like 350 pounds or 170 kilograms, long distances, to break down castle walls or just bomb your enemy. The Lord of the Rings, of course, has a good example of the catapult and the trebuchet. I'll attach a couple links, you can check it out. Either way, right, the catapult, which has elastic potential energy, and the trebuchet, which uses gravitational potential energy, that potential energy that's stored is converted to kinetic energy to be able to launch these objects. All right. Let's move on to B2.3 on kinetic energy in motion. Kinetic energy is the energy of an object in motion. So any object that's moving has kinetic energy. Here's the formula we use. Ek equals 1/2 mv squared. The units of all energy is joules, which is, of course, kilogram meter squared per second squared. Here's a few examples for us. So Bart on his bicycle has a mass of 65 kilograms and is riding at a velocity of 10 meters per second. What is Bart's kinetic energy? Kinetic energy is 1/2 mv squared. So 1/2 times 65 times 10 squared. Now we get 3,250 joules. I want to look to significant digits. This one's got 2 significant digits for the mass, 2 significant digits for the speed. And so, if we go ahead and put this in scientific notation, we'd have 3.3 times 10 to the third joules. Okay, take a look at question number 2. A car has a mass of 1,200 kilograms and travels at 100 kilometers per hour, which is 27.777 meters per second. What's the kinetic energy of the car? Ek is 1/2 mv squared. So 1/2 times 1,200 times 27.777 squared. You have to use, because of the units, right, up here, the units are in kilogram meter squared per second squared, and so I want to make sure that my velocity, or speed, is going to be expressed in meters per second, okay? So the calculation. All right, I get 462,937.0374. That's a lot of digits. So now let's take a look at our sig digs here. We've got 100 kilometers per hour, that's 3, and 1,200 kilograms, that is 4. And so we're going to go with 3 significant digits. And so it should be 4.63 times 10. Now count how many spaces here. So we've got the decimal point right here. 1, 2, 3, 4, 5. So times 10 to the 5 joules. And question number 3. A horse has a mass of 800 kilograms and has a kinetic energy of 260,000 joules. How fast is the horse running? So when we use the formula here, we need to solve it for the unknown here, which is the velocity, or speed. And so what we can do is we can put in all our numbers. We have 260,000 in on the left-hand side, and then 1/2 times 800 times v squared. Well, what's a half of 800? 400. So we've got 260,000 is equal to 400 times v squared. Divide both sides by 400. Just going to come down a little bit below here. And so 260,000 divided by 400 is 650, but that's equal to v squared. So we need to isolate v. So we square root both sides. And the square root of 650, 25.49. Now if we take a look at the sig digs that are given up top, 3 sig digs, 6 sig digs, and so we want to round it to 3 significant digits. And so I'm going to have 25.5 meters per second. Thank you very much.